Yeah, thanks a lot, Brent. And yeah, I don't know if caching is fun. I knew I would be in trouble going after David because it's not gonna be as awesome as what he just showed. And as a matter of fact, just to point out what Farzad said, I actually already used the diagram from stale-while-revalidate in a product demonstration for my product team. It's pretty awesome. It helped us a lot already. So yeah, let me get started by sharing my screen. I just pasted in the chat the link if you want to follow from your own browser, because yeah, I'm also in Berlin and our internet connection is famously horrible. So yeah, I hope I don't get any big issues, but if you want to follow from your browser, it should be possible. So yeah, this talk is a little bit about cache, and it's not always a fun topic. It's not going to be anything super mind-blowing, I imagine, but it's definitely something useful for everybody building for the web, I guess. So let me get started. So the first thing is that screen is not shared. What the heck? Okay, I hope it is shared now. Can you see my screen, please? Oops. And I just yeah. Okay, cool. So there you go. So that's, I need to take this thing out here. Yeah. So, well, so first of all, let me get my bad jokes out of the way. So this is not this is not a talk about cache with SH. It's a talk about cache with CH, and it's definitely not Jerry Maguire's cache that's in there, and that's actually where I took the name of the talk. So I'm explaining my own joke like the old man that I am. Sorry about that. So yeah, this is not a talk about money, but maybe it is. If you were here in the first days and you watched the talks on the first days, I think you might have a different conclusion. You might understand that cash is about money in the end because, yeah, helps a lot and so on. But I'm not here to talk about I'm here to talk about technical implementation, so I'll let you all draw your own conclusions by the end. But yeah, I'm already jumping ahead of myself, so just let me get a fresh start. So first of all, yeah, as Brent already said, my name is Attila Facina. I work here in Berlin, but I'm originally from Brazil. I like to create content. I try to create content, and you can find me on all those places. You can always reach out and have a chat. And just to be like super clear, my background is very heavy in the front end. I'm not like super expert on a back end. What happens is that when I found out about Jamstack and serverless, when it showed up on my map a few years ago, I just saw an opportunity to build more interesting things. Like I never had like a background in computer science and this kind of stuff. My background is actually completely different. So I just jumped in head first. It just felt that it would simplify a lot of stuff for me. So with zero understanding about and concepts about backend development, I just fell hard into a very deep rabbit hole. So today, the plan is just to bring you my take on how I found to understand cache in order to make the things that I was building more reliable, more stable, and actually to perform better. Yeah, and from my own perspective, what makes the apps more deliverable and yeah, so more performant. I'll try to go, I know we're pretty much out of time, so I'll try to go without rushing too much, get to a point where we make in time, at least in time to not eat our suppers super late. You get in time. If you are in Europe, as I am, if you are in other time zones, maybe Brent is waiting for his breakfast instead of dinner, but anyways. So yeah, and feel free to make any comments on the chat. I'm keeping my eye here. And thanks a lot, Brent. Yeah, so feel free to jump on check. Now I have my eyes on it. And what I planned for today is just we'll talk a little bit about some of the what's around cache, basically so we can just align what I mean about some words and terms that I'm going to use. And we will also talk then about where we cache the stuff that we cache. And I want to be clear now that I'm talking about web cache. There are other kinds of cache that are used in programming, but I'm talking mostly specific about web. And finally, I want to get about to show you a little bit of the how, some few ways that I like to use to deal with cache. So maybe you have some takeaways out of that as well. But yeah, you're probably thinking, okay, I know what. That's cache. What my point here is actually like cache is not something that we just flush. Like we tend to think bad things about stuff that are just there for us to flush. So and that's actually not the purpose of cache. And cache is not a villain. And in fact, that would be a more appropriate title for my talk. And if there is no other thing to take out of it, it's is that. And I just want to, yeah. So in order to do so, we need to first have a look about what cache actually is and what are the things that make the wheels turn when we're talking about cache. So in order to summarize this whole the concept, in order to fit in a tweet, I think the point of cache is actually reusing previous fetch resources if they didn't change, because the worst problem is when a resource actually changed, you're getting old stuff. That's the point where we feel like throwing our machines on the wall. And ultimately, that's worse than not doing cache, is doing it wrong. And we have all been seeing a change in perspective of how cache is seen. As I mentioned, there were other talks about that. If you saw what Max is doing on Graph CDN for cache, if you had a look about SWR, the fetch library from the Vercel team, it uses cache very, very heavily. Remix and also Next.js do it also in a great way. And Zeta also showed a little bit on Teja's talk. So you probably have seen the same thing as I did, where we're actually starting to use cache more and more. And it's not that cache is becoming better. It's actually that browsers and the platform is actually using cache more appropriately. So not long ago, we were still supporting i11, and i11 had its own unique quirks about how to invalidate cache and deal with that. So it wasn't not as reliable as it is now, but now it's possible to do nicer stuff. But yeah, some of you might be looking at it and saying, yeah, that I don't use any of those, but that's a non-exhaustive list, and your browser relies a lot on cache. Your end users' browsers rely a lot on cache. So if any, I hope that understanding cache is going to make you a better web developer in the end. And the first important concept on talking about cache is understanding what cache freshness is. And actually, it's a state of our cache. And it's basically when the cache is below its expiration time. And after the expiration time is done, then we consider our cache stale. And expiration time can actually be determined by 3 different ways in this order. So you have the max age. You cannot see my screen, Rafa. You see a gray background. Okay. So yeah, so you can see the slides. Okay. Yeah, okay, cool. Awesome. Okay, so yeah. Okay, so we have these 3 different ways of defining the cache. So the first one is the max age directive, which we're going to talk a little bit more later, and it's defined in seconds. Then if the max age is not present, the browsers or the platform, in this case, not necessarily the browsers, could be the server, will go for the expires directive as well. And the expires is defined by the time where you say it's supposed to expire minus the current date. So it's basically a way of calculating what max age is supposed to be as well. And if none of this happen, then we have some heuristics defined for it. And the heuristics is a little bit more complicated, and it can depends a little bit based on how it's determined in the documentation. So I left a link over there on the slides. So if you're following on your own, you can click that. If not, I can share the slides later on. So the basic algorithm for defining the cache freshness is the response time plus this freshness time minus the current age, where the response time is when the client received the response, and the current age is the seconds since that response was generated. But yeah, we still need to determine freshness in this case. So to calculate freshness, we take the date, which is the time the response was originated, and we subtract the last time it was modified. And then each platform can determine what the base they're going to use. The most common one is 10, but the spec actually allows it to be determined in different grades. And yeah, so that's basically how you determine the freshness and how the browser determines when the cache is supposed to expire. So what this means is that if the cache is past the expiration point, it's considered stale, and then it's going to try to revalidate the cache or try to fetch a new resource. And that's about it. And that's how cache is supposed to work. And then we have a few strategies to dealing with cache. The most common one, probably the most famous one, is Revving, which actually has nothing to do with Fast and Furious and has nothing to do with the revving of an engine. It's actually based on revision, but it was cooler to put a Fast and Furious GIF over there. So Revving is actually very good for resources that are going to change without a pattern of frequency. So basically that's what we do with, we used to do with our static resources. So CSS, JavaScript, this kind of stuff, when you serve through a CDN and we have that hash on the file name or on the query string, that's basically what we're doing. We're changing, we're changing the revision of that resource. So it's very good when you have interdependent resources. So for example, you're changing the HTML, you're changing the resource, your JavaScript depends on your HTML. And once you update your JavaScript, you don't want the HTML, the old HTML to fetch the new JavaScript, or the new HTML to fetch the old JavaScript. That's usually when you have weird quirks. So it's really good for that, because once you flush both of them together, you change the hash, then you know which resource is fetching from which place. So you can forcibly fetch a new resource. That's usually what we do with the query string. I don't know if there is too much difference nowadays. In the past, we should not use query string as a default alternative for the hash because some CDNs would not consider the query string for storing the resource on their cache. So essentially using the query string in a file name would not work. And there are different ways of building your hash, as you probably already know, which can be based on date and can be based on the content. And just out of curiosity, I had a look at some of the more famous serverless providers that we have. And actually, they do some caching validation, and they don't actually use the Revving. They do the validation in different ways with headers, but yeah, you have Netlify, which I don't really know. I couldn't find. I just found a really old article about how they do caching validation. So they do instant caching validation. Vercel actually uses another header that we're about to see to handle the based on the deploy. So every deploy actually invalidates the cache. And fly.io uses a combination of different resources that we're going to see in a few seconds. But Cloudflare actually has something really interesting, which is CDN cache control, which you can actually set a header that will dictate to their CDN how the CDN should handle your cache, and not only use the same. And if you want different cache control strategy for the browser and for the CDN. But yeah, I don't want to get too much ahead of myself. Let's talk about validation, because what we saw right now, Revving is really good for invalidating the cache completely, but maybe you don't want to do that. Maybe what you want is actually to have a check on the CDN if the resource actually changed. Otherwise, you don't do anything, you don't fetch. And that's where validation headers come in. So the first one, as we saw on the Heuristic Freshness, last modified is the standard fallback. So it's basically a time where it tells when a resource has been generated. And then the heuristics automatically determined. But then we have the e-tag header, which is an entity tag that represents the content. And that's supposed to be carried by each request and response. And then we have the vary header, which is basically a directive that tells a list of the headers that impact the response. And there's actually a funny thing about the vary header. It's actually not intended for this. The original concept of the vary header was actually for developers to be able to share different resources on the same URL. So basically you could say on the vary header in the request, like if you were requesting an HTML, then the server would know they need to respond with an HTML, or you could say a very like JSON, you would get a JSON, very CSV, you'd get a CSV, and so on. So the vary was intended for that, but yeah, we all realize now it didn't work like this. The web doesn't work like this. So what the vary does so far is basically dictating what are the headers that influence the response. And we're going to see a few examples of that. But first, the e-tag. So the e-tag has two possible values. One of them is the string value, and the other one is with that W first. And the W actually means that's a weak validator. And the weak validator is actually means that the resource, the content on the header and the resource are not equal byte for byte. So this is actually what is more recommendable if you have a website with static content, for example, dynamic content, I mean, sorry, which means that the hash is not going to change, but the content may change. So that's the point of the weak validator. So a few examples on what's usually used for creating the hash. So you can have a revision number, and you can have a timestamp, or you can have a content hash, like an MD5 content hash or something like this. So which one to use basically depends on what's the pattern of renewing your resource and how expensive it is to generate that hash. So MD5 hashing can become expensive to your server. So it really depends on when you want to force the revalidation of your cache, when you want to have the revalidation of your cache. So any of those are possible. Just the W actually indicates when the content and the response are not byte for byte the same. And then the header, the very header, has this special directive where you are not actually passing a list. And this means that different things, different variables than headers are going to influence your response. So yeah, that basically moots the point of using it for cache handling purposes. So yeah, that's not entirely recommendable. And the most common one is used based on the accept encoding header, because the accept encoding is basically going to say how your CDN or your server is going to encode the content it's sending down the wire. But that's can become a really, really big problem if you don't normalize your response. Otherwise, you might be caching the resources too eagerly, and they're not actually going, you're going to be caching the same resource multiple times. Take this example, for instance. We have two different ways that accept encoding is declared. So this is probably like Safari and Chrome or whatever, different browsers. One of them is saying gzip or deflate, and the other is saying gzip. In the end, what your CDN is going to do is send a gzip response. So you're going to have the same response, but because the header is different and you didn't normalize the header, the cache in the CDN is going to be different. So in the hypothetical scenario that the first request happens and it gets cached, and then the second request happens, it still needs to go all the way to the server and get the response. They don't get the cache. So ideally, you can normalize that. And yeah, it's just another if statement. So this is something that I could recommend you doing if you have, like, I wrote JavaScript because that's what I do. I write JavaScript, but it depends on which kind of server you have, obviously. So the first one would be to, if it's BR, it means it's brutally, which is the most aggressive form of encoding. So if your browser can accept brutally, send brutally. Otherwise, you take gzip, and then as you see, we are changing the headers here. And if not, just remove it, because then if you're not gzipping, or if you're not compressing, then you don't need to cache. Then you cache all of them the same way, because it's always the same. So regardless of which header comes in. So for the modern web, you'd be more or less pretty much in the safe area if you do something like this, I would say. And yeah, that's essentially how you get. So yeah, so now we talked about invalidating cache, we talked about handling cache, we talked about some of the best practices, but now what we actually want to do is actually control the cache. So we establish a pattern on how the cache is actually going to do, and the cache just obeys. So we have, yeah, I cannot resist a Gollum joke, so I'm sorry. So the most important, and it's actually the cache control is, there's a bunch of directives. I'm going to mention here the most used ones. So you have the max age and the no cache or no store, or the private and public. So the max age is a response directive, and it's determined by a time in seconds for how long a response will be fresh since the time it is created. And then you have the no cache and no store, which actually they're complicated, because no cache does not mean you're not going to cache that. What no cache tells is that the response must revalidate before it's being used. If you want to not cache your response, we actually want to use store. So essentially you read it as don't store the cache, or like revalidate a cache, essentially. And then the private and the public is going to determine where the system is able to store the cache. So if it's private, it's going to be private for the user. So it stores on the browser only. And if it's public, it basically can store anywhere. So it's going to store the cache on the CDN, wherever it's going down the wire, and then in the browser as well. And then you have the other directives that we're going to see in a little bit more detail, which is immutable, must revalidate, and stale-while-revalidate. So the immutable one is it's basically how we say don't update while it's fresh. So that's basically the cache directive we used back in the day when we were revving or adding hashes to our static files. Basically, we say cache for as long as you can, and actually that max age is a hint because not all CDNs cache for forever. They actually, like Vercel, for example, caches for 31 days, I think, something like that. So it really depends on which CDN you're using. So the public is going to say cache anywhere, and the immutable says, yeah, don't even revalidate. I'm saying for as long as max age is good, for as long as it's fresh, don't even go anywhere. Just use whatever you have. So that's the point of immutable. You're avoiding the revalidation point. And it's, as I said, it's really powerful when you're combining with revving or cache busting in this case. Then we have must revalidate. And it says, once the cache goes bad, you need to revalidate before you can actually use it. And the difference between, and you might think, okay, this is the same as must revalidate or immutable, but the point is, if a resource goes stale and your cache for some reason is not able, your client is not able to connect to the CDN, if you only have immutable, you're going to bring the cache version. And when you say must revalidate, it says, okay, if I cannot revalidate if my cache is stale and I cannot revalidate, I'm not going to use it. So that's the slight difference that can make or break the UX for you. Yeah. And then my favorite one, which is stale-while-revalidate. Word of advice, it's relatively new. So double check with your CDN if they support that before using. I know Netlify, Vercel, at least this serverless platform, I think all of them support, but yeah, double check. So essentially you can say, in this case, we're saying, yeah, the max age, my cache is going to be fresh for 1 week. And then what I'm saying here is that between the 7th and the 8th day, if my user requests this resource, I want you to serve them the stale content while you fetch for the new resource. So then it eliminates the latency for updating the cache, while it basically under the hood, it's going to update it. You can pass it as I put it there with a time frame that's the max age plus the time you want the stale-while-revalidate to work, or you can just pass stale-while-revalidate and then it's going to be stale-while-revalidating forever. And yeah, that's really powerful one, and we're going to see right now why. So as I mentioned, like I want to bring some real world examples. So I'm going to show you some ways of using the cache control headers on a Next.js app and on a Remix app, because that's what I'm about lately. I really like those two. I cannot decide. So on Next.js, there are 3 different patterns that we can use. So the first one is using edge functions or like a middleware. So essentially, if you're not familiar with Next.js middlewares, it's something that we put on the file system based routing. So the middleware is going to intercept the response on the edge for each route, each sibling route or child route. So in this case, if I put that on my pages directory, on the root of my pages directory, it's going to intercept every request that I make. So in this case, I'm going to intercept the response, and I'm going to apply my cache control header to every response that is going there subsequently. So this is the like one file. You rule all your routes on Next.js, including API routes, everything. It's going to be served with this this cache control. So be careful. Then we can do something similar, which is not actually using cache control, but with get static props, where yeah, so we have something that's going to, like, any method that's going to create the props for that page, and then we stipulate a revalidate of 10 seconds, and that's the 10 seconds that Next.js is going to wait to re-render your page. Finally, we have the get server-side props, which is actually something that I had to look up at the docs, how I'm going to intercept this to affect the cache control. And we actually can. You can get from the context, you can get the response, and you can set a new header there. So you can basically do whatever you want. You need to be aware, though, that the get server-side props, it behaves differently. If you're doing like a code navigation, it's going to render your page on the server and then push it out. So if you're typing it on the browser or if you refresh it, that's what's going to happen. If you're doing a client-side navigation, it's going to send an API request to the CDN and send down the serialized response. So in this case, the props over there, it's going to send down the wire as a request. So it depends. This cache is going to be applied in different ways if you use it like that. And next, Remix. Remix is rather simpler because they have a different kind of API. So they have this loader function. And the loader function is how you fetch data for any route in Remix. So you can, the same way as get static props, and then you can reply with something, with whatever headers you want. And by default, Remix applies the headers of the loader to the page as well. Okay. And cache control is so cool that we can actually fake incremental static regeneration with Remix with them, because Remix is server-side render only, but with cache control, we can say something like this. So I want the max age of just 10 seconds, and you are stale-while-revalidate forever, or for 1 day, or for 1 week, or whatever. And this is basically the same effect as the revalidate 10 that we just did on Next.js. So this is a cool pattern. And yeah, so those are the ways that I can find off to use that on the Next.js and Remix. And just to finish up, like a conference, not a conference without a goodie bag and swag. So I just put some cache control headers and directives that I usually use, like the quick recipes if you just want to copy paste something. So you have the come back tomorrow cache, you have always check no matter what, you have always update by always serve from cache as well. And finally, you have only yours for a day, maybe 2, depending on how often you request, or hours, which means you're going to cache in different ways. Yeah, and yeah. So that's it. Unfortunately, you didn't see me skiing for the first time in my life and falling in my face multiple times. So I'm leaving you with this little GIF. And yeah, maybe next year you can see me having awkward accidents in the snow. So yeah, thanks. I'm sorry. I think I ended up taking the whole half an hour in the end, but yeah, I hope you found it. I hope you liked cache a little bit more and didn't find me too boring with this.